So hello everybody, and yeah, I'm really happy to be here in Sofia in Bulgaria. It's the second time I'm here, and it's actually I think the first time where we managed to kind of like have this type of event. When kind of like we planned this event here, it was very interesting for me and intriguing in a certain way, because you know I kind of like did some fair share of talking at conferences where you stand up, basically you walk around, you talk, you present something, you do some demos. But now kind of like we wanted to do something together, so me with Bulent. So the reason why we wanted to do something together is that usually when we kind of like meet on Teams and we start discussing about technology, we kind of like spend a lot of time discussing things and said, okay, let's do something together here in Sofia, because kind of like maybe we can discuss something and some other peoples might be able to attend. And I was also looking and I was seeing this type of conferences or talks or keynote talks where you kind of like just had two experts sitting on a stage next to each other and, well, just chatting around, you know? And I said, okay, let's try to do that. So it's the first time that I personally do something like this, and I think, Bulent, it's also your first time. So we are a little bit nervous, obviously, but what we want to do today is just have a chat between us, but with also you. So from time to time, we might have questions, and we might kind of like, well, have some different points where we might want to also hear your thoughts about some topics. So please don't be shy and feel free. It's just a friendly talk between us, between nerds, let's say. So we can simply just get involved and say what you have to say. Now, at the end of the session, we'll have a dedicated Q&A part. So if you have some more kind of like, let's say, important or more complex questions, or I don't know, things that needs a little bit more discussion, let's just have that at the end of the talk. And we'll kind of like discuss, and also over a beer maybe when the event is ready. So we'll definitely have a lot of time to do things. Okay, so I think we are all set. Are we? Is there anything else? Is there anything else? Did I forget something? I don't know. Hopefully not. So what will we talk about? Microservices are evil. Who does believe that microservices are evil? Okay.
Oh,
Who doesn't believe that microservices are evil and it's a really great thing? Okay, just one person. So I would have expected Bulent to be exactly the opposite, I guess, no? Because
personally,
yeah, but let's just go forward. So I really didn't understand what Vesela did talk about us. So so Bulent,
good
let's.
words, good words.
Oh yeah, hopefully, but. Let's make sure that people here outside Amdaris that kind of like understand us. So why don't you share a little bit about well your experience as a developer, architect,
Yeah,
nerd in one
yeah.
word?
Okay, thank you very much calling me nerd. So I'm glad to see so many people attending this event this evening. First of all, let me express my excitement to see you here. I started my career in mid-90s, honestly, as a student in Sofia University. And since then, I am actively working as a developer, architect, manager of teams in different sizes. Went last years primarily in the management track of great teams. Last about 2 years, I am a technical director in Amdaris. During these 20 plus years of experience, I went through different technical domains. Of course, back in 90s, I started in a short period of time, I was a web developer on the backend side, writing C++ engine with CGI, if you ever heard about it.
So was web development with C++ a thing?
Yes, exactly. This is my
Okay.
first professional experience. Then I moved to the native Windows development stack, worked for outsourcing companies, spent almost 4 years developing computer graphics for Corel Graphics Studio. Then moved to Telerik, spent I don't know how many years working on the native engines that Telerik has behind their controls. Then moved to the web development again in the cloud solutions and platforms they provided. Spent a couple of years working on AI back 7 or 8 years ago building NLP-based chatbot solutions.
So just let me interrupt you. So you were working with AI stuff
Yes.
7 or 8 years ago?
Yes, exactly.
So just notice, AI is not something that started last year or 2 years ago with ChatGPT.
Definitely. Actually, we managed to sell a very promising solution. It's active now, native chat. It's still available. But yeah, last year and a half, this is a big boom in the AI, especially with generative AI. But this is a different story. Probably we can organize another event and we can share some knowledge about it. But yeah, but last, let's say, I don't know how many, 5, 6 years, I'm primarily concentrated on creating web solutions, I would say, enterprise-grade solutions for different type of enterprises, from such that are very restricted and require a high level of security of everything that you can imagine in one solution, to such that are more relaxed and there are not such a big needs solutions to be very scalable, or so, from small to big solutions and with different requirements. Actually, I'm here to share my knowledge in a succinct manner with you, but is it possible? I don't know. How short we can explain all the stuff that is coming in the upcoming 1 hour, I don't know. That's why a lot of questions could emerge, but let's see. It will be an interesting journey.
Okay. So I assume, when did you work on the microservices project the first time? Do you remember, did you get there and the project was already existing? Or was there a decision, it's a new project and yeah, let's start with microservices?
It was 2017. I think it was when we started cloud native, but I wouldn't say cloud native, a solution that's only hosted in the cloud on the VMs, but yeah, in the end, it was a very first attempt to create something based on microservices. We didn't fail just because of the scale of the application. Was it the right decision to use microservices? Definitely not. But 2 years before that attempt, there was a big hype. Microservices, this is the panacea that will help us to solve everything we have as a problems in monoliths. And then I said, okay, we have the power to take the decision. Let's use microservices. In the end, we ended up with 3 or 4 services. They were not microservices, they were services, tightly coupled, no worries, but in the end, it was a working solution that works until today. That's why.
But each service worked in its own process, no?
Yeah.
Yeah. Great achievement.
Great achievement.
Cool. Yeah, so just a few words about myself. So I'm also technical director here at Amdaris, but I'm located in Romania, in Timișoara. And obviously Bulent has way more experience than I have, because I just started to work in IT, I think it was 2010. And yeah, basically I have 14, 15 years of experience in this IT industry. And in that time I've worked for kind of like bigger companies like Microsoft and for Amdaris mostly. I had just also another short period of non-Amdaris, but it was only 6 months and I came just right back. So yeah, it was like the lost son. So yeah, but from when I started to basically work a lot in IT and development, basically, one of my core priorities or things that I really enjoy the most is try to share not my knowledge, but my experiences, the things that I go through, the things from which I learned. So I kind of like was involved a lot in fairly different types of educational initiatives. So I did teach programming in kind of like schools like the Telerik Academy here in Bulgaria, but not here in Telerik, something similar in Romania. I did also teach and still teach at the university in Timișoara. But I also kind of like went one step further and I kind of like have my own YouTube channel. So I said, okay, I really want to do my own stuff the way that I want to do it. So if you want, you can check it out. It's mostly for .NET developers, at least for now. So, but I think the videos around software architecture and discussions, they're kind of like they are still valid for other technologies as well. And that's basically my experience and who I am.
Done.
Yeah.
So, how do you find this energy to be so creative? Because I'm following your channel. Literally, probably every 2 days, there is a very promising video with a lot of content that is actually valuable. You know, YouTube is full with video that you can just skim in 5 seconds to see that nothing valuable is there. But every single sentence that you say is valuable. How do you manage to create this?
I think it's kind of like very easy because usually when I create videos, it's not, I don't usually create them for views, for clickbait, for stuff, although, well, I have a few videos that I did for that, but usually I don't do this, and kind of like the work as a technical director is very important in this case because I get in touch with a lot of projects because as technical directors, we overview the technical quality of different projects and we get to kind of like, yeah, understand what the challenges are and how we solve, how we tackle these challenges. And basically a lot of ideas for these videos, they come from that project. So I just build something around that idea, some simple stuff that I can mimic, that I can replicate and show what the problem is and how we approached in solving that problem. And I never say that the approach that I propose in my video is the only one and that it's the best one, that it's the best practice. I hate it. When I hear people talking about best practices, I really hate that because best practices are usually not best practices except maybe in every context. So it's always a matter of context. So obviously there's room for discussions around that. Not every choice is kind of like the best one. But I always think that the most important thing when taking decisions is not that you take the right decisions. Obviously, that's also important. But I think more important than that is that you take informed decision. So if you take an informed decision, even if in the long run turns out to be kind of like not the optimal one, it's still way better than taking the right decision without the needed context and well, back information for that. So that's how I create videos, that's how I do stuff. I basically take things that I encounter at work and try to explain them in videos, more or less. So that's it.
Just one thing for the audience. Don't think that we have many problems in the company and this actually drives his channel. So the problems that we have from technical perspective, we solve them. Yeah, you know, technical issues are the simplest issues in this world.
Yes, but it's how communicate how we did solve this. So that's basically the thing. And one of the things that kind of like are very, very mind-boggling nowadays is still this idea of microservices, because kind of like let's go to the next slide to have this just as a reference for the discussion. But I remember this morning, me and Bulent, we just sit basically at the office, and I was looking at kind of like some articles, and basically the first result for a search was kind of like something from AWS that was saying something. You should definitely go for microservices because it's cheaper than a monolith. So I think we did have quite a laugh then.
Yeah,
I think we'll understand basically, or we'll try to understand during this discussion why actually going for microservices is not always, or probably most often, it is not the best idea. And we want to start actually this from this idea of a sales pitch, because no, I think wherever you go to read something on Medium or YouTube videos or wherever you go, you always hear great pitches about microservices. And what's the very first thing that you usually hear? I think it's kind of like this idea that, hey, you know, Netflix does microservices, so you should do it in your startup as well, isn't it? Yeah.
Definitely.
And yeah, then you say, hey, if Netflix does microservices, so maybe we should do it also. Even if my company is kind of like a small startup and I'm doing just an MVP right now, but yeah, let's go microservices because Netflix does it. So how often do you think that this might be a good idea?
Not too often, but let leave this answer for the end
Yeah,
of the presentation.
Yeah, yeah, exactly. So the idea is that usually kind of like that's people that promote this idea of sales pitches about microservices. They kind of like usually have some hidden agendas. Like if you like the article from AWS, obviously it was biased because they want you to buy their services. Obviously, you know. So, definitely you should do that. But then kind of like there are also a lot of different kind of like promises that comes with these microservices. No, they say you will be able to deploy more often, to deploy independently. You will be able to have more agility in your releases. You will kind of like reduce the cost. You will kind of like have better team efficiency and better team productivity. You will implement features faster. So they always make you a lot of different promises like that. And the thing is that, well, promises, especially when you see them basically in sales pitches, similar to what we have here, and that's basically something that we did take out from the internet, basically. So yeah, it's what you see daily when you search about something, architecture, you will see things like that we have on the slide, which obviously will bias you. Because you will say, hey, kind of like it's very repetitive, and you get the repetition, get the repetition, get the repetition. So it might become automatic. Then whenever you need to take a decision, hey, I will do this because here, these are the promises. But then again, how fast do you think we can, for instance, implement a very simple feature in a microservices system, like displaying a user's birthday on a profile page?
Oh, it depends again.
It depends, okay.
Yeah.
Okay, can somebody give some estimates? So how long do you think, I don't know exactly what projects are you working on, but if they are microservices, so we are talking only microservices, how fast could you display the user's birthday on a user profile page or settings page?
Depending, do we have previous knowledge of how to use microservices?
Okay, you already have a system with microservices, so let's say that you have probably.
A hint, you need to reach the user's microservice. That manages users' information and everything. You need to change the front-end side because in this architecture, usually you have a decoupled from the services, a front-end implementation.
Yes, like micro front-ends.
Like micro front-ends. And if you have the chance to use micro front-end that is not communicating with the given microservice that you need to use to get some information, welcome to the jungle. You need to have to extend your backend for the front end, or to have some kind of additional extension to the aggregates that you need to have on the backend side.
Yeah. There are a lot of things. And
a lot of things too. And if we reach the problem, how can we update the user information from this micro front end? I will ask you how you can ensure the consistency of the data that you will enter. Imagine that another user, another admin is reaching this information at this right moment. What do you do with the consistency? So it depends.
yeah, so trying to answer this very simple question, we have prepared actually a video for you, so let's go further. And I want to play for this video, it will be only 1 minute and 45 seconds. What we play, the video is longer. But please take it like this. This video is obviously kind of like an over-exaggeration, but I think you will definitely see, if you work on microservices systems, I am fairly sure that you will find things that are very similar to what you've witnessed in day-to-day practice. So let's just play the video.
Just one feature. Why is this taking 3 years? Look, it's not that simple, all right? I have priorities, my team has deadlines, we have other deliverables in progress.
I'm still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we get this done this quarter?
Look, I'm sorry, we've been over this. It's the design of our back end. First we have to call the bingo service. See, bingo knows everyone's name-o, so we get the user's ID out of there. Then from bingo, we can call Papaya and MBS to get that user ID and turn it into a user session token. We can validate those with Umnap, and then, once we have that, we can finally pull the user's info down from Raccoon.
Yeah, but couldn't the Raccoon team basically just...
No, Raccoon isn't guaranteed to have that info. Before we do this, we have to go to Wingman, do a query to see if the user's willing to take it to the next level, or if they're just playing the field. Now, Wingman is cool, but he doesn't store any user info himself. He has to reach out to other user info provider services, like RGS, Barbie Doll, Ringo 2, BLS. But how does it know what all the user provider services are? Well, for that, it has to go to Galactus, all-knowing user service provider aggregator. And while Galactus has omniscient knowledge of all current user info providers, it doesn't have future sight or knowledge of past user info providers, so it expects a time range. To get all the current user info providers, we need to pass a time range with the current time and a time representing the end of the universe, which we get from EKS, our entropy chaos service. EKS is being deprecated at the end of the month for Omegastar, but Omegastar still doesn't support ISO timestamps like they said they would a month ago, so until Omegastar gets their fucking shit together, we're blocked. We can't get signed up for our use case, we can't use EKS, there's nothing we can do. So Galactus won't be able to find our new birthday boy provider, which means Wingman won't know how to talk to anybody, which means I won't be able to find true love and I'll die alone. Pathetic little thing. You know nothing.
Yeah, let's just move to the next slide now. No, it doesn't really move.
No, the focus is here. Click on the page.
Okay. So, is this familiar to you, for those who worked on microservices? Like, obviously it was an exaggeration, but at least all the experiences that I had working with microservices, that's quite spot on, I would say, isn't it? Like, even the simplest things that you need to do in a microservices system is not simple, is not easy. So usually it kind of like involves a lot of things. And going back to the discussion that we have about this sales pitch now, the problem is that people that propose you and say that you should definitely do microservices because Netflix does it, because you have these promises, actually, most of them, they are very, very biased because they try to sell you something because often this comes together with, hey, I'm selling cloud services, so obviously I will benefit from that. Or, hey, you know, I'm a technical architect, I'm a consultant, I can help you out with that. So I just propose you to just do microservices because it's the way to go. And then I can help you with that if you want. Obviously, you have to pay some extra fees. You have to pay me, to pay my visits to your company, to pay trainings that I will deliver to your teams, no? So, and I will help you. And that's why, actually, what happens is that basically people usually created what I would call this church of complexity. And basically everywhere, that's one probably of the biggest problems of software development nowadays is complexity, because everyone wants you to do complex stuff. But adding complex stuff or doing complex stuff doesn't really actually help you. It doesn't really bring any value to your application. It doesn't really bring any value to your customer. The only thing that brings value to the customer is solving a business problem, solving a business need. Now, how you solve this business need? Do you need microservices for that? Probably, or most probably, in most of the cases, you don't really need to do that. But this church of complexity basically created an entire narrative around, okay, why do we need microservices? And what they don't tell you, usually, is that basically there are a lot of drawbacks and downsides that you bring in your system when you try to go for a microservices architecture, like decoupling nightmares. Like when we decouple services, actually that brings really a big problem with that. So maybe we can kind of like think a little bit, okay, what problems does decoupling bring without entering into the messaging part? So things like node management, like, I don't know, node registrations, like, I don't know, things like that, basic things that we have in distributed systems. And I know that you use tools that kind of like abstract this away from you, for instance, for kind of like node management, like you use Kubernetes or things like that. But that will actually hit you at a certain point when your service discovery doesn't work.
Yeah.
So it's actually really a nightmare, because in order to kind of like have a microservices architecture, you kind of like need to fundamentally understand what distributed systems are. Now, if you think 30 years back, distributed systems was something like a very frightening idea, and basically it was something like nobody touches this unless it's really needed. And in fact, with microservices, it's the other way. Everybody says you should definitely do it. You don't know how distributed system works, but you introduce all the problems of distributed systems in the application that you are building. And you are not even aware of the problems most of the time you do that. you then just got also infrastructure complexity, I guess, but also some more practical stuff like teams. How do we manage the teams? How do teams work when you work on microservices? Then troubleshooting, yeah, troubleshooting and debugging. That's really a nightmare when it comes to microservices. And yeah, we definitely have overall a thing that nobody tells you about is that running something on microservices is definitely more expensive than using a monolith. So we'll see exactly why they tell you that it's kind of like less expensive and why they aren't right. But let's talk about decoupling, and kind of like in this discussion we'll already see, we'll just concentrate more about kind of like this part of messaging and what do we need to do there, because what is one of the first things that you will realize when you start working with a microservices project? Because the pitch is, yes, you have independent services, every service needs to kind of like do something, and it's kind of like very nice and cool. And obviously when you use a to-do application to demonstrate a microservice in conferences or things like that, it obviously works and it's perfect. But the moment you try to actually use it in a real application, you will find out that, hey, actually those microservices really need to communicate with each other. So,
Should they communicate?
okay, that's a good question.
Yeah.
Should they communicate with each other, the microservices? Okay.
Really?
And how? And why? So,
When?
no, when you say something and we challenge it, it might not be wrong. We just want to challenge it. So, just as simple as that. So the question is, once again, should we have microservices?
Should we have microservices in the first place?
This question we'll answer at the end. Now I want, yes, now we want to go through all the nightmares and the potential complexities, and then try to evaluate and try to put some weight on those, and try to understand if it really makes sense or not, and even what alternatives do we have. Because we have some very smart alternatives to it, isn't it? So. Yeah, so we will answer these questions more towards the end. But let's assume that the decision was already made because we had a sales pitch. So people just convinced us at a conference and reading some articles and watching a video. So we want to do microservices. And that's really the first basic question. So should microservices communicate with each other? Then I'm curious what's your opinion about that? Depends on what?
If it's needed.
And how you define if it's needed or not?
Well, by the business requirements.
Okay, so BAs need to be aware of microservices so that they create business requirements that kind of like adapt to the microservices scenario.
We should be aware about the services at all, first the business services. So we extract the technical for a second from the business and we say, we are interested how many, what kind of services are there, which services are running in parallel in the business, which are crossing each other, and when, and how, and who, and what, and so forth. So definitely there is communication between business services, just we need to know when, why, what, how, and so forth. So yeah, this is structure.
Okay, but can somebody give maybe an example when you kind of like need this communication?
To exchange data. To have overlapping in the data that services need, for example.
Let's try to give the classic example with microservices,
Okay.
no, with an e-shop, no? Like it's a very, very classic one. So do you want to start shipping an order before you got the payment, for instance?
Yeah, for me as a client.
Yeah, and then eventually just cancel the order and you still receive it because the shipping has already begun. So it's a win for you as a client for the ESOP. So actually,
Actually, it exists. Like I don't know how it's here in Ukraine. Like you can order, it can go to like the delivery. Then you can like see what you have, and then you can pay.
Please.
yes, this is a method that you can pay when you receive. That's okay, something else. But let's assume that you need to pay online. It's just online payment.
For a digital product, let's say for products like digital audio workstation software.
Or for Bitcoin, yeah.
You have demo usages. Like you get the product, for example, for some time, and then you pay.
Mhm. Yeah, but this is the demo version. It's just a regular product, not a demo product. But do you think it's okay for me to just place an order? I already received the product, but the payment is not processed already. Yeah.
It's not okay, definitely. So
Yeah. So exactly, that's actually the first problem so I remember when I first worked on my first microservices project, it was exactly that. So I was having this kind of like dream idea that each microservice is independent, it knows what it needs to do. Kind of like you would have some very basic stuff that you need to communicate through async messaging and that would be okay. But what you will find out in most of the projects is that for almost really every business critical scenario, services need to communicate with each other. Obviously, that's what you find out. How they would communicate with each other, that's the next question. But you see, when we already start talking about microservices, we haven't even really started to implement them, and we already basically touched on a very basic topic that we, as an audience, as people here, we couldn't really agree upon, you know? So do we need this direct communication? Some people said yes, some people said no. So you said that already we just started and we already hit a roadblock. Like if you go for a regular monolith, that's a no-brainer. So that's something that kind of like you know exactly how you should do that. It's very easy because it's everything in process. So you you don't even realize that this type of different small components depend one upon the other, but the moment that you extract them to microservices, that moment you actually have this very first big challenge, which seems to be a simple one, but in fact it's a very complex one, because okay, how can services communicate with each other? So what type of communications did you use for microservices? Synchronous, asynchronous. And you see that here on the slide, we have this synchronous, and it says it's a kind of like an anti-pattern. And this is from an official documentation about microservices, let's say. Is it really a type of anti-pattern to have the synchronous communication between microservices?
Sure.
Okay. You are sure? So you agree with that, or you don't agree with that? Okay. Does anybody think differently about that?
I do not agree.
Okay, why?
Because very often this is the proper way to do communication. With microservices, synchronous communication may be a bottleneck, but this is because of the infrastructure, because the way it's implemented in a monolith,
Okay.
synchronous communication is the way to go.
Mm-hmm.
And it's fast and simple, and you have the result immediately.
Okay. So, yeah, I would tend to...
So keep in mind that in microservice architecture, you have an extra latency added in communication. Monoliths, they are in one process, there's a direct API calls, near to zero latency, okay? But in microservices, microservice to microservice communication, especially if it's asynchronous, and imagine that you have one calling another, this another, to fulfill this request calls another. This is a blocked, temporary coupled chain of waiters. They are waiting the last one to finish his job. Then this to process and to finish his job. Then this to process and to return, let's say, response to the client. Including the latencies in communication, if any, but sometimes, always, there are from small to bigger. Imagine that the third service is in a different cluster somewhere in the West Coast, like 2,000 kilometers from this data center. This is a very big latency accumulated that actually impacts negatively the final result. Are you okay to wait 15 seconds just to visualize the user data? No.
And I know you will say, we have CDNs, we have stuff. Yeah, we have them. But you just add and keep adding complexity to your system. You just keep adding complexity to your system. And do you know Kelsey Hightower? It's, who does know him? Nobody. It's kind of like a very, very prominent developer from Google, like a principal, more than principal, I don't know. He's kind of like, well, black guy, but he's kind of like very, very, very smart one, and he does a lot of conference talks. And I've watched him and listened to him in a lot of different conferences. And he actually had a tweet fairly recently. It was kind of like this debate about performance and throughput in microservices versus monolith. And he was giving this example that that's actually a no-brainer because monoliths will always be faster than microservices. It's just a matter of simple arithmetics because in a monolith, you just have one call, you get just one result. It might take a little bit longer to get it, but in the end, if you have microservices, you will end up having hundreds of different calls one way or the other. So with all the latencies, that's really a no contest. So microservices on themselves won't be faster than monoliths. Obviously, there are techniques to optimize this with CDNs, with a lot of caching, and I don't know, a lot of different stuff. But in the end, it's kind of like more and more complexity. But let's come back to this idea of communication. So we hit this roadblock. We are not sure yet. So some of us think that it's an anti-pattern to have direct communication or synchronous communication. Some of us think that it might not, and in some scenarios it might be actually useful. And the answer, or my answer to this, is that we are all right, actually. So that's the bad thing about this one is that we are all right. So on one hand, you shouldn't have synchronous communication between microservices. But on the other hand, you will soon realize that for business critical parts of your application, you need to have this. But then the question comes, how do we do the synchronous communication? What options would we have there? REST, okay. Is this a good idea, bad idea? What did you mean? Please, can you repeat? Okay, why?
We can ensure that the messages we want to send will be eventually delivered, and we can do that relatively.
Eventually. We'll come to this. Let's assume that we are a team right now. Yes, we are a team, and we have decided as a team, I don't know, you might disagree, because that's how things work in a team, but we have decided that for some scenarios in our services that are business critical, we want to have synchronous communication. So that's the decision in the team right now. Now, the next question is, how do we implement this synchronous communication? And the answer was that we can do it with REST, okay? And the counter question is it okay to do it with REST? If yes, why? If not, why?
It depends what we want.
Okay. Can you extrapolate a little bit, maybe give an example or articulate a little bit more in depth what you were thinking about?
So first of all, it's kind of standard, and we like what we start with.
Mm-hmm.
Then it's fast. It's stateless. So
Okay.
Why it can be not good? Because for example, we have as an alternative GraphQL, for example,
Mm-hmm.
and we want to have a different set of data. Yeah.
Okay.
In order not to get
Yes, but GraphQL adds another layer of complexity, and in the end, it's still HTTP, so it's the same. Okay. Do we have other options? gRPC, yeah, correctly. So please? SOAP. No. Let's not go there,
Why
okay?
not? This is an option, please.
Yeah, it is an option, definitely.
I remember these big XML payloads that we transfer through wire. Please, it's an option.
I mean,
it still exists in the bank area.
I know. Unfortunately, I know that SOAP still
Banks use
exists.
COBOL systems still, so that's why it's not.
Yeah. Yeah, but let's not go there. let's not go at that place. No, but it is definitely an option. But yeah, then we had this idea of gRPC, which actually it makes sense. Doesn't it?
gRPC is, from my perspective, I really like gRPC.
Okay, but
It's
why?
fast. It's small payload that's transferred to me, and you can easily protect it.
Mm-hmm.
In the end, you are exchanging binary data.
Yeah, indeed.
And from security perspective, back in time, I implemented this licensing communication with license service using gRPC, encrypted it twice.
Okay.
And it was like, and in the payload, they don't know which field what it means, because you don't have the, like in the rest, key values. You have just number to the value. But what is the value? Who knows? If you create the payload with encrypted value, and on top of this encrypted, because it's encrypted through the TLS channel communication, you are well protected. Man in the middle, good luck.
Yeah. So gRPC is really also, I think it's a very viable option. It's definitely the only point I disagree with what you said is with HTTP that is fast. It's not fast. it's slow. Yeah. Yeah. But
it's easy. Let's say.
Yeah, it's easy. It's easy. It's a standard. It's kind of like, I totally agree with that. But we have this gRPC option, which is tempting, yeah, as you said, Bulent. So it's tempting.
For service-to-service communication, I usually prefer gRPC.
Okay. So we can then implement the service-to-service communication with gRPC. So who on the team knows what gRPC is and how it works?
You can learn it.
Usually nobody. Yeah, but it's still, it's another decision that we need to make. So we haven't even started to really develop something, and we already have hit a lot of questions for which we cannot really find one good answer. It's just kind of like a trial and error, and let's try this out and let's try that out. Obviously, the next thing would be, okay, for some services, let's try some async communication. There are some different patterns there. Like usually you would use a message broker. We will talk about this just in a few minutes. You can do also even, I don't know, maybe HTTP polling. So we are already basically in a lot of unknowns. Like, do we do something that's an anti-pattern? Don't we do something that's an anti-pattern? Did we choose the correct thing on how to communicate between services when we want to have just synchronous communication? So we are already in a very, very bad place. And then there comes the next thing. So, okay, let's say that we have figured it out, but how do we talk to our microservices? So obviously a very naive approach is, okay, let's have a front end, I don't know, talk to each microservice. So is this a good idea? Like, if you have hundreds of different microservices, so yeah, okay. So you should have an entry point, and that's what we usually call an API gateway, or something like that. So suddenly you need to add basically a new layer to your application, which is the API gateway, which kind of like has different roles to aggregate requests, aggregate response, try to do all the stuff and talk to the needed services. But basically it's a huge work that you kind of like, you need suddenly basically one guy or a dedicated team that they will only work on the API gateway. So you didn't have this so far. But we can even go one step further. Does this API gateway work for mobile clients and for web clients or for desktop clients? So did you work with API gateways when you were doing microservices, and what was your experience with those? Was everything going through the API gateways?
Honestly, if the communications are really, really small, it's a very small system that accidentally uses microservices. You can use API gateway as the only entry point to the microservices. But in fact, this is not the case in 90%+ of the case in the solutions.
Because what you will see when business analysts, we have quite a few business analysts here, will start to write user stories for you. If you kind of like have also a mobile frontend and a web frontend, you will suddenly receive that the requirements for the mobile frontend are not always the same as the requirements for the web frontend. And kind of like in the web, you need to display more. In the mobile, you have to display less. So suddenly, the API gateways and the contracts, they're kind of like they don't really work anymore. So what do? We add another layer. So as programmers, we always solve problems by adding new layers, basically, to our systems. So we add what is commonly known as a backend for frontend. So we'll have basically a backend for frontend for the mobile application, We'll have an API gateway that will talk to the microservices. We'll have a backend for front-end for our web application, then an API gateway that will talk to the services for, and get the information that are specifically for the backend for front-end. So here's just another layer. So we just made one short step forward, and we suddenly ended up with 2 additional layers in our applications, in our system. And believe me, adding new layers to a system is not something that you do in a day. So it's not something that's kind of like fast. Obviously, there are services that provide API gateways or whatever. You don't kind of like need to develop them from scratch, or not always, but you still need to work on them, configure them, define contracts. We'll kind of like enter into some of these topics. But once again, from decoupling these microservices, we already have some new challenges, some new complexity that needs to be solved by writing more code and adding more layers to that. So, and then comes really the pain point. What about distributed transactions? So
for transactions
what about
in general,
them? Yes.
let us don't call them distributed transactions.
Okay.
So in monolith, it's easy. One query to the database, or one command to update the data in transaction. Everything is consistent, yeah? What's going on if you have a few microservices that need to update the database with data that will go from one consistent state in the overall data sets to another consistent state, only if all of these updates are done successfully. But there are different microservices responsible for the partial of the data.
Mm-hmm. And we'll look into some patterns about that. But one thing that's actually, from my point, important here, like transactions. Like everybody, when we think about transactions, we think about like also what Bulent mentioned, like this idea of having kind of like consistent data and make sure that it's always in a consistent state. And most developers think like that. And they say, okay, we have kind of like patterns like sagas. We'll have them on screen just in a few seconds. So that's how we achieve that. But then we will do a review like me and Bulent, and 90% of the cases happens because nobody thinks about transactions isolation level.
Oh.
Because transactions are not only about ACID. It's only about, okay, while a transaction is ongoing, what can actually others read? What data can they actually read? So you also need to think about transaction isolation levels when you think about transactions and distribute them basically in a distributed system. And then you get into patterns of distributing data and transactions, which is really a total nightmare, and it's, I would say, a science in itself. What do we developers do, or not we developers, but some consultants and people that usually push microservices? They come forward with solutions that seem to be very, very easy. Like, for instance, we have this idea of two-phase commit. That's an approach through which we could solve this type of problem. But the thing is that not every system supports two-phase commits, or not all databases support that, and it might not be kind of like possible to implement it. But the idea of the two-phase commit is that kind of like you have a central kind of like place, a central microservice in the end, basically, that kind of like defines, hey, that's exactly what the consistent data is, and all other services basically need to obey to that. And that kind of like would also emit some information about when data needs to be updated. But then how do you do this database updates? How do you know that all services have the same level of data information? Then there are other things that come here to hand. You need to have distributed write-ahead logging, for instance, to make it resilient and to make sure that kind of like you can redo the state. You need to kind of like implement other different patterns maybe to make sure that kind of like that data is always consistent for all the services. So it's kind of like, it turns out to be very complicated and not always possible. So then consultants come with this very great
before this, I don't like to face
commit
just because it introduces latency and it's not scalable. Why introduce latency? On the first phase, you ask your microservices, please lock the database, because on the second phase that's coming, I will ask you to do an update.
Yeah.
And the coordinator in the middle is waiting for response from these services. Are you ready with your lock operation? In the end, when all of them acknowledge, I am ready, waiting for the second phase, which will be commit, because all are ready, you send the commit, let's say, messages to them. But what if one of these microservices responds, no, I'm not ready and I'm not going to do this? Then you need to revert all of the other locks, send messages to all of them, but this takes time.
Yeah.
In
So
the end, you
they
have
are
a
very
window.
chatty, I would say.
It's very chatty and very looking pattern. That's why I don't believe that it's successful pattern, my honest approach.
Probably it's not, and probably most people have discarded it. And there's another big problem with that, I think. So it comes, how do you implement two-phase commits?
Oh, no.
Because usually kind of like, you can't really do this on HTTP level.
Definitely, message broker, definitely very well tested way of communicating for every single transaction that you have defined in your system.
Okay.
You need to have a very good, let's say, flow of what is needed. And if you change the contracts, if you change the database, you need to update this, not media, coordinator for the two-phase. It's very hardly maintainable.
But I think I read recently an article by Martin Fowler. Basically, he also co-authored a book of it's called Patterns of Enterprise Architecture. No, well, Patterns of Distributed Systems, sorry. Patterns of Enterprise, it's another book.
It's very old and very good
but
book, by the way.
This one is a new one, like it was released in December, and kind of like they don't speak directly about microservices, but about real distributed systems, like when you are aware about what means to have a distributed system. And there's kind of like also one very good point, kind of like overlaps a little bit with the experience I have, that usually when you want to implement two-phase commit, you implement it at a networking level.
Yeah.
So you either implement it via TCP, which is kind of like bad, or you implement it via UDP and you don't know if it's worse or better. But the advantage of UDP is that kind of like it supports broadcasting, and it's kind of like a little bit easier to kind of like implement that. But it's still this idea that
it's not consistent. Do you know if the message will be received or not? So you can lose.
That's the downside of it.
I cannot understand. For gossip protocols between services and meshes, I can use UDP protocol of communication because I don't care if any of the package is lost. Because it's a gossip. It's really continuous.
But here you lost.
Yeah, I don't care if one.
I think that it's also about the statistics of how probable is that packages get lost. So
this is
obviously, yeah, it's kind of like, it's kind of like a point of discussion. Obviously, I don't propose kind of like a final solution to that, but it's definitely
this is a
something
good experiment that we can do actually. Okay.
It's something that we need to take into consideration also when we kind of like have this. So, okay, we don't like two-phase commit. So yeah, let's just discard it. Sorry that we have included it in the presentation. But it's definitely a pattern that's kind of like, you will hear a lot about it, and whenever there is microservices, you will hear this idea of two-phase commit. But because developers hate it, and kind of like architects started to hate two-phase commits because of these challenges, we came with another magic thing. Let's have sagas. And sagas will save the world in the end, no?
If you say.
Until they probably won't, because, basically sagas are some patterns of messaging in asynchronous messaging systems, in which you kind of like, define how you want to do this communication depending of what you want to achieve. There's kind of like these options of having this choreography, and basically kind of like here you kind of like have a central point, basically that orchestrates really the communication with each service. Hey, you need to do that, receive the answer, then with the other service, receive the answer, and kind of like also has this mechanism of reverting or going back, or reverting basically everything to a previous state, which obviously sounds very good and nice, but it's very complex to implement. So it's really complex to implement sagas, no matter what type of messaging protocol are you using. If you're reading, I don't know, AMQP, or if you're using other types of protocols, it's always kind of like very, very hard to build. Then we have this Saga orchestration, where you have usually end up having an entire microservice doing only orchestration. So how do we solve problems as developers? We add layers, we add abstractions, and we add other services that helps us with problems that we have in other services. So yeah, we have a problem with something, we add another problem to it, and we think we solved it. So
Actually,
we nailed it.
Saga solves two-phase commits problems, but adds additional weaknesses
Yes,
to the system. But yeah, Saga orchestration is probably the easiest one to implement with these compensating requests that are waiting. You know, they are waiting. If something happens, okay, let's execute compensating requests in order to roll back. And eventually, everything will go well, and we will not be executing them. But in the end...
But also, even here, you've got other problems, because sometimes you might not be sure about how messages are received, or if they are received, and how do we solve them? Well, we have other patterns, you know, like the outbox pattern. Then we introduce the outbox pattern in a Saga. So we have really a lot of things. So I think that the one thing that we want to take away from this part is that kind of like, obviously, when we started microservices, like this decoupling, this promise of decoupling, actually adds a lot more complexity than we would even think about it. Now, we'll see a little bit later, when we add complexity, it's not just that we add more code. It's we add the need of more developers, we add the need of more kind of like dedicated roles for specific sub-areas of the systems. We add complexity in a lot of other stuff, which ultimately will translate in higher costs, like when it comes to total cost of ownership. But let us, Bulent, what you say we go to a next area and talk a little bit about another type of complexity that microservices bring, which is the infrastructure complexity.
Yeah. So until now, we touched a little bit to the complexities from the implementation part of the system. Yeah. Even we didn't talk about how we decide what is a good example of a microservice. Even what microservice means. Is it really micro? Or is it just a label? How big it could be? How we can design it, starting from the current database or from the business requirements? These are very broad topics that if we can spend hours talking about different approaches.
Indeed.
So, software implementation. So, implementation from the software side is difficult. What about the infrastructure? Do we have DevOps in the group here who are dealing on a daily basis with infrastructure that hosts microservice-based architecture solutions? Okay, so I will try to show you a kind of mid-level problems with infrastructure. There are higher and more sophisticated problems for sure. So, at first, one of the promises of microservices is that the architecture is scalable. Yeah, it can grow in horizontal scaling instead of what we have in the monoliths, vertical scaling. Adding bigger machines will be what bigger hardware specifics. But now we have horizontal scaling. We can replicate the services according to some rules.
Yeah. Sorry to jump in, and that's actually a false promise once again, because you can definitely horizontally scale a monolith. So
yeah, you can.
Obviously, you just have another thing about a small complexity that you need to have a common cache probably or something like that. But you can definitely horizontally scale a monolith. So it's basically a bad argument because it's simply not true.
Yeah, okay, let's then say with microservice architecture, you can easily horizontally scale because they are stateless, the microservices, because they are small enough, because we have containerization right now as a technology last 10 years is widely adopted. Do you know when containerization actually was used and is part of the Linux kernel as an option? In the 90s, there was a containerization in the Linux kernel enabled, but only a few people probably knew about it. Yeah, for example. So containerization is not something new. It's just democratized technology right now with Docker efforts to to bring it much closer to us, mere mortals that are not smart enough to learn such complex things. So in the end, in order to scale, you need to introduce an additional software, let's say, like Kubernetes, Nomad, Docker Swarm, name it, OpenShift based on Kubernetes. Many of such kind of systems allow you to define your clusters, the nodes in these clusters, and rules how the hosted microservices as a pods in Kubernetes case to scale horizontally and to replicate each other according to some parameters like CPU utilization, memory consumption, etc. But what if I want to scale horizontally a particular microservice in case that my message broker has 1,000 messages in the queue? I cannot do this with Kubernetes. I need to introduce additional software like KEDA, that is event-driven autoscaler that communicates with Kubernetes autoscaler and pulls information about the integrated third-party message queue if it meets the requirements for additional replica for a particular pod. Instruct the Kubernetes autoscaler, please add additional pod for this microservice because I have this rule defined. So it's getting complex. And do you know, so probably you don't have experience, but how much effort it costs to DevOps guys to configure Kubernetes cluster to behave adequately manually on, let's say, VMs on a data center that is on-prem, for example. It's a nightmare, believe me. On top of this, usually clients came and say, we want everything to be secure. How to secure a system? Okay, there are fancy words, zero trust networking, everything in a private network, service-to-service communication to be absolutely encrypted. Client doesn't care that this introduces additional level of latency, yeah? Because there are standards like FIPS, like SkyGIS in USA for government systems, etc.
And it also introduces a lot of new set of different costs.
Exactly. And then what we decide as an architect, okay, can you do this? Yes, I'm an expert, I can do this. But to do this, I need to introduce additional technology stack in my infrastructure. Let's add service meshes. There are products like Console, Linkerd, Istio, that actually orchestrate additionally. So this is a layer of additional orchestration of the communication between your services by ensuring that they have certificates, valid certificates, that they can find each other, that you can define your policies, which service with which one can communicate in order to restrict. This adds additional technology on top of everything.
Let me make sure that I understood correctly. So service meshes are basically orchestrators at the network level, more or less.
Yes, they are a kind of technology stack that at lower level, in the network level, allows your service-to-service communication. It's listening for the liveness of your services. It can communicate with your Kubernetes autoscaler. It definitely communicates in order to know if there is a new pod, for example, in Kubernetes case, replicated. Physical addresses of this pod must be communicated back to the service mesh control plane in order this control plane to update its service registry and to inform the, you see these proxies that are sidecar proxies in the pod attached to the internal network of the microservice to inform them where they can find the services for service that they want to communicate with. And actually, control plane acts as a kind of load balancer on a lower level for service-to-service communication. But on top of everything, you need to have a sidecar proxy in this pod. This means either, usually sidecar proxies are based on Envoy. Envoy is a very good solution for many different cases. But in the end, there is a hot reload of all of the parameters. What I can do in a real life system, I can update the policies for communication, and control plane can update the sidecar proxies in order they to know how to react on the upcoming calls. It's a very complicated but very promising, let's say, lower technology that we use in zero trust microservices backend. But this is another complexity on top of everything that we have. It's not just Kubernetes. It's not just KEDA. It is service mesh that is integrated with them. Then you created something really fancy, very secure, very resilient, scales really well. But you cannot deploy it continuously just every time to run manual stuff. You need to introduce infrastructure as a code solution to write as a code all of your infrastructure, and then to use different systems like Terraforms, Ansible, etc. to update your infrastructure accordingly. So this is another level of amount of knowledge that you need to have in order to continuously update, in order to meet one of the promises of the microservice architecture, continuous independent deployment, etc. Is it everything? No, no, no. When you have so many microservices, you need to build them. You need to create a continuous integration, continuous deployment by utilizing different products like Jenkins, Bamboo, Circle CI, whatever you can imagine. Just because this is how you can meet this promise. Fast deployment.
And we'll see that in practice, probably you can't meet this promise in a lot of cases, like with the birthday that we had the video earlier. It was kind of like the typical case, I think, where you theoretically can meet the promise, but practically, like, you can't because you have a lot of dependencies.
Is this everything? No, no, believe me, it's not. Do you know what cloud-agnostic architecture means? This is something that I've got a case where a client came and said, I want microservices architecture-based solution. Whatever you can imagine as a security to be implemented, this is the solution where I put service meshes at max. It must be deployable on laptops for my sales managers in order to be able to demonstrate it. It must be deployed on any data center that our clients, government agencies, has locally protected. It must be deployed on any cloud, and it must be lightweight enough. It must be scalable, because people who are going to use it at one agency level are probably like 10,000 on a daily manner.
It must be deployed in Docker.
Where?
In Docker, definitely, to run local.
Docker.
Yeah. So containers are
by default.
By default. And I was like, okay, can you do this? Yes, I can. I am an expert. And then I was like, cloud-agnostic architecture. Back in these years, it was like not trending and catchy word, but it was like emerging technology, cloud-agnostic. Back then, there were not solutions like Dapper in order to create an abstraction layer for integration with different types of database services. And this is another sidecar that you put along your microservice in a container in order to have this communication. 1 or 2 years later, Dapper emerged the market. I was like, why I didn't have you 2 years ago?
Yeah, but the Dapper, I think it's mostly for the .NET world. No, it's not?
No.
Okay.
So this is something that, but this solution was on .NET too, so that's why. And I was like, okay, cloud-agnostic architecture. You just cannot imagine how much complexity it adds when you have, I want everything. It's much easier. I want an Azure native solution. Oh, I have services. How much money is the budget for monthly? It's like 2,000. Oh, 2,000 per month for 20 or 30 users. Perfect. But the case was not like this. And in the end, you end up with something like this. You see, you have a cluster with many nodes. On every single node, you have pods that are horizontally scaling. They are monitored by the service mesh that sends metrics information to the Prometheus. That these metrics are visualized in Grafana. I will talk about them later, etc. And this is a very ordinary and simple, actually, architecture of this solution.
Even for a microservice where you just need to display a birthday, so.
Yeah, and when it comes, let us display the birthday in the front-end UI for this. No, I cannot do this because I don't have this communication between these services. I need this data from here. I need to update my BFF. And you give me only 1 day. I can do it in 1 sprint. This is what happens in fact. What else do we need? You think that it's... No. Don't forget to test your solution. You have the infrastructure, you have the software code base created, but what about testing? Do you know how to test solutions that are based on microservice architecture? It's a really difficult to meet all the requirements for good QA practice in such kind of solution.
I think it's very easy to explain this because it's kind of like, think about everything that we did talk about until now, and really everything you need to test. So really everything, from the messaging to all the different layers, the abstractions, everything you need to test, everything.
So you see the pyramid of tests. Do you see that it has more layers than the usual one? It's just because of the microservices. Unit tests, you know them, great. You use them, I believe, with good code coverage. Integration tests. Every microservice somehow communicates with other services.
What's even an integration test in microservices?
You need to test this integration for every single microservice. Contract tests. Believe me, if you don't have contracts, a well-versed established contracts for communication, APIs that a microservice exposes, you will fail.
I'm not sure if it applies in your experience, but in my experience with microservices till now, the most common problem that we had in teams that kind of like worked on microservices was simply one team changing some of the contract of the other, and no one knows, and suddenly the system doesn't work anymore.
Exactly.
And no matter how much planning you put, these type of things will happen when you have microservices. You will have contract violations, and suddenly everything will start stopping.
And
we will start working.
One of the most difficult things is to convince developers to create these contracts and to maintain them, to version them, and to do not change them. Usually what happens, until release 1, everything is like this. Everyone does whatever he wants, updates everything, continuously complaining, QAs, the system is down, what's going on? I changed the expected value. But why front-enders don't know? Why this team that works on these microservices don't know? So it's very difficult. Then, component tests. In the end, every single microservice is like a software program that has internal business logic implemented. You have to test this internal behavior. This is isolated test. Solution integration test. Okay, we have we need to test how it scales. Yeah. Does it scale? Yeah, it scales. But according to the rules that we have, is the elasticity good? Okay, let's execute some load tests against it to see how elastically it will grow. Performance tests, you see, after we need them, so we need to have this, to know these limits that the system will be in life, and it will be reachable, let's say.
Yeah.
Another non-functional requirement, the easiest one, to be reachable. It determines the SLA of the system. And of course, what clients actually like to do is exploratory testing. In the UAT environment, they need to click on the buttons. And for the client, believe me, what is behind the scene, they don't care. They just see that you show the birthday here and you have this button here. And for them, having a button here is equal to draw this picture in the front end. Is this everything? Believe me not. How are you going to troubleshoot this infrastructure and this system?
Yeah. I think that's kind of like the very simple thing that actually comes here is, or the very basic problem that we have always when you started to work on microservices, obviously there are solutions to it, we'll talk about that, is, okay, how do I know why this order failed? Because like, to place an order, you have hundreds of microservices kind of like doing their stuff, some of them just orchestrating, some of them just being orchestrators, some of them just being Saga, some of them, where did it actually fail? So that's
it's not feasible to drill down in every single container from the CLI to check the local logs to see what is registered in this instance. What about
the state of each database of each microservice
disappears? You know,
correlating IDs and
this is one. Just a second. When the container is not in a faulty state and it's not responding, orchestrators just remove it, and you don't have chance to go and to see what's going on inside. Why? It's blocked. You cannot see. What you need actually is a centralized logging. Why centralized? Because you need to have a common place with a kind of common structure of the logs in order to be able to filter them, to see what is the problem, where it is coming from, and to understand. But as Dan said, if you have many related to each other requests that actually form one whole, let's say more abstract, you need to correlate them in order to get
what
the whole
belongs together.
Yeah, correlation ID is a must for such kind of logging. And believe me, usually if you don't have a very good logging, the system, even if it's written, you cannot maintain the system. It's impossible. And here we have a different solutions, hopefully. You don't need to implement from scratch. You have Elasticsearch that's together with Logstash and Kibana, with Fluent Kibanas too, and Elasticsearch, you can create a very, very durable, I would say, and very promising solution. And of course, OpenTelemetry is introduced as a standard way to describe the logs in order to have a unified language for the microservices to communicate to you as a developer what is the problem with that they have.
So I think that's actually very funny, because for quite some years, just using correlation IDs was kind of like a standard to kind of like correlate different microservices and events and see what belongs together and that. But still, this posed a lot of different challenges, because not always was this working appropriately. So what do we do as developers? The next thing that we like most, develop standards or specifications. So basically, we developed a new standard, which is the OpenTelemetry, which kind of like introduces a standardized ways to basically do monitoring, and probably more than monitoring, I would say, but it's a new standard that kind of like defines a way through which basically systems communicate and can aggregate information based on what happened on your system. And right now it's kind of like a trend, I guess, to introduce OpenTelemetry everywhere.
Almost everywhere. Support is added as far as I checked it previously. Okay, so
all these problems that we mentioned, which are all technical problems. So till now we have faced this decoupling, then infrastructure, but kind of like we did talk only about technical problems. Now the thing is with technical problems, at least what I witnessed in the teams that I was working with, is they always bring team problems. So technical challenges bring team challenges, like people start to argue, people start to disagree, and in the end, people start to kind of like, not hitting deadlines, basically. So we estimated we would deliver this feature in one sprint, but it took us 4 sprints to deliver it. So why is that? Is our team maybe dysfunctional? Do we have problems in the team? And the answer is that a lot of times it's actually not a problem with the team. So it's not that the team is dysfunctional, it's that the entire delivery model is dysfunctional. Because what happens is that usually when you work with microservices, you end up having, or if we stick to the theory, each microservice should be kind of like responsible for, or each team should be responsible for one microservice. But obviously in the teams that I worked on, not always did the customers have the number of developers to have dedicated teams. So it might be that you have one team that's responsible for 2 or 3 services, another team that's responsible for other 2 or 3 services. And the thing is that here, when it comes to a microservices system, when you need to introduce a new feature, like the one with the birthday that we had a video on, it's kind of like not that you go to a team, like the user profile team, and say, introduce me the feature. No, this feature needs to be orchestrated. So first we need to implement the time standards in the video, or to make sure that I don't know what raccoon or whatever thing here that there was. So basically for each new feature, no matter how easy it is, you would have to orchestrate this as a team level, like planning. So for this, you kind of like have these vertical teams, and each team comes with its dedicated roles, but we have this horizontal, I would call them maybe requirements or definitions of what we actually need to do. And then we kind of like need stuff like people, team, that would do this orchestration, basically, and try to understand exactly, okay, if we need to do this the team A needs to do first the first thing, team B should do then the second thing, team 3 should then do the other thing, and then we are able to deliver the feature. But what happens usually with microservices is that team A, team B, and team C, they have all different release timelines and different priorities. So you need to get the birthday, but the other team has to implement the payment first. So what's more urgent for the business? Usually you would save the payment, but then the users will complain more about the birthday maybe. They don't care about the payment. They don't want their money to be taken away. So you have kind of like, teams will always have different release timelines if you work on microservices. So you definitely need to orchestrate and to work on that, to basically orchestrate and make sure that all the release timelines actually fit together. And that's obviously very difficult to do. And who needs to do this actually? Does a BA need to do this? Does an architect need to do this? Does a senior developer need to do this? So who does this actually on the team? And
it's not me.
Yeah, it's not me. Usually it's not me. And usually we just pick somebody, I don't know.
Yeah.
So you are not responsible for that. Usually it's the architect. If we have an architect, if not the most senior person that you have in all the teams, you pick, hey, you do this now. And obviously that's kind of like work that requires both very deep technical knowledge, but it requires also very deep project management knowledge. So you need to find people to actually accommodate that. If you really want to solve this problem for real, like solve, let's not really solve, but you would kind of like hire dedicated staff that are specialized. We have people that are specialized on kind of like doing this type of stuff. The consultants that pitch you microservices, for instance. Yeah. so you definitely have options to do that, but what a lot of times happens, and because no, they say microservices are fast, they are about agility.
Absolutely.
Okay. So we just take somebody from the team who seems the most knowledgeable, and hey, you do that. So that's it. That's how we usually solve this problem. It's not the best way, but this is what happens in practice. And yeah, basically, this needs kind of like on additional architects probably also, I said, or dedicated roles for people that would do that.
With all these technology stacks and domains that explained infrastructure, software, how many people you know that are with this wide knowledge that knows how to orchestrate these technologies in one solution? How many?
Who? No. No. But if you want to grow in your career, the best thing, try to widen your knowledge to understand all this stuff, and then pitch microservices to companies and then sell them consultancy to kind of like solve their problems, and you will be set for your lifetime. I can guarantee you will be set for your lifetime. But actually, what you said here is kind of like very, very important, because when you start working with microservices, you will soon realize that you kind of like need to hire more people, no?
More experienced people.
Yes, and they will come usually only experienced in certain parts, so you have to hire a lot of different people that
To
kind of like
overlap and
to
fulfill
do
the whole
those
picture.
meshes and I don't know
Yeah.
what other types. So, and this is something they don't tell you, because you will arrive at the point with your microservices in which there will be nobody kind of like that will be deep enough in really all aspects of what's involved to be able to solve very complex problems. And in that case, you would just need, as you mentioned, Bulent, kind of like an expert in service meshes, an expert in kind of like service communication, an expert in different areas, because you will hit the wall where you can simply just go further with your knowledge. YouTube won't help you with real stuff. On YouTube, you find just, well, hey, do this because it's a best practice, but it will never help you with this type of complex problems, so you can forget that. Maybe, I don't know, ChatGPT doesn't really help with these problems,
No,
so
this knowledge is
he's very stupid when it comes to this. So when it comes to, hey, write me some 10 Python lines of code, it's really very good. It does the job. That's how I prepare my courses at the university. I teach also Python, and I obviously don't have very high Python experience, but kind of like I use ChatGPT to write my demos there. So it's useful
Dan,
for that.
I'm almost ready to prepare myself for retirement, because everyone says that ChatGPT Copilot, they will make me useless for this industry.
Let's have this for another talk. Maybe you will invite me in Bulgaria again, and we can continue to talk about AI, because that's another topic that I'm very passionate about. But the idea is, or the core thing that I want us to notice here is that kind of like, to solve these problems, we will have problems in the teams due to the lack of knowledge, due to the different release timelines, due to the different prioritization, basically. And to solve these problems, we usually end up by the need to actually add more stuff to the teams. And they don't tell you usually this, but it's kind of like, obviously, that also adds a lot of costs.
In this case, you see that between different teams, we need to have shared knowledge. Not only for schedules to align ourselves, but even in the front end, we have a front ender and the back. Even in the front end, if we apply microservices problems to the micro front ends in the front end layer, these micro front ends handled by different teams, they must be aligned in terms of design, in terms of UI UX used, in terms of communication between them. They must be accommodated in a common shell with good patterns for popping up, going down, with communication channels, with sharing states, using the common state. So this is a kind of standard, let's say, agreed upon blueprint for front-end development that all of the teams, front-enders in these teams, must follow blindly, because standards are because of this. To have a standard that actually defines the outcome in a common way, and no surprises to be introduced. And not only this, everything, deployment ways, infrastructure as a code, who is handling what, responsibility sharing between DevOps in different teams. This is a really difficult inter-team communication.
And suddenly you have this another challenge, which is totally non-technical. How do you share knowledge between the teams? So you need to kind of like plan dedicated sessions for that, dedicated formats, find the best formats for the teams. Guess what? That's time that developers won't spend developing. So guess what this translates into? A slower release schedule and things like that.
Let's say today a very good friend of mine, being in the public, wrote me a message. They waste my time in useless meetings. This is a very, very, let's say, experienced person who is doing job in the meetings that is below his level, and he's wasting his time. His added value is not here. He's here. He must be engaged with this type of stuff.
And kind of like all the things that we have discussed right now boil or comes to this very, very specific point, especially in a time like this when kind of like things are not very clear in the IT industry. Like, why are our systems so expensive? Like, customers and companies suddenly realize that I pay a lot for my microservices system. Yes, you pay a lot because the sales pitches, they simply say microservices are cheaper because they just like compare you how can you horizontally scale some microservice versus how you can vertically scale a monolith, and it will say that kind of like it will be cheaper, which might be true, but they never take into consideration what we usually and CTOs always measure, this total cost of ownership. Because if you think about the total cost of ownership, everything, literally everything that we discussed today adds or has a price tag. It translates into money. Literally everything, it translates into money. And there are a lot of companies that kind of like even go or near bankruptcy because of kind of like, yeah, they just don't have the money to kind of like pay for their microservices solutions for things that they kind of like don't really need. So the idea is, and I will go very fast through this, is that kind of like the pitch, what it usually does, it pitches you, hey, you say, I need something that flows on the water. And they say, here's an iceberg. It flows on the water, yeah? Because you see the top of it, but you don't see the bottom of it. But instead, you could just have a raft, you know, and it still floats on the water, but you don't have all the hidden complexities that kind of like have more cost. So in the end, what the promises of microservices give you is kind of like, first of all, most of them are really not realized. And second of all, they have a 10 times or even more higher cost, basically, than a corresponding modular or monolithic solution. But is there a place for microservices, Bulent?
Yeah, definitely there is. But only in case that you really need to build a complex and scalable application. So
when I mean scalable, I think, let's think planet scale.
Yeah.
Like, does my application really will have the amount of users like Netflix? If your answer is no, and 99% is no, then you don't need microservices.
Don't deep dive in this domain, especially if you didn't consider all of the layers of complexity that will be added in this application. And there is a quote that we get from Martin Fowler's article, written actually 7 or 9 years ago.
Mm-hmm.
Yeah. Usually, we start with a monolith. Once we understand exactly what the client wants, what are the needs, because usually at the discovery phase you cannot take the right decision. You need time. The client needs time. You need to get some paychecks from the client to see how billable he is in that. Let's be honest to you. And then you will decide much better, we need microservice architecture or not? So if someone came and said, I need to have 10,000 of concurrent users, but there are 10 days in the year that we must be able to handle 100,000 of concurrent users in the Black Friday, in the Black Monday, in the Cyber Friday. Okay, let's build microservice architecture, but you need to explain to the client all of these pitfalls and expensive entrapments in your road in order he to be aware what is coming.
Okay.
Otherwise, we dramatically will fail.
So what could we do instead, Bulent, here?
Yeah, instead, from my perspective, we can start with monolith, but modular monolith that in need later we can easily, I will say easily, split to microservices.
And that's the topic for our next event.
Yeah.
How do you create a modular monolith?
Exactly, how to build modular monolith.
But yeah. So yeah, that's the part for the Q&A. I guess we are over time, I guess.
Yeah,
no?
hour and a half.
Heavily? Okay,
Heavily.
just half a minute. So,
One question.
yeah.
It's related to the last page of your PowerPoint. You say basically that we need to use microservices when the application is complex and scalable. who, when, how do we measure that an application that is going to be built is going to be complex and scalable? So do we rely only on the users? Do we rely on users and the complexity of the service that the users are? So I just don't want to go there.
Obviously,
What is on the table telling you, what you need on the table so that you can judge and conclude it is going to be complex, it is going to be scalable?
Obviously, I will give just a very simple answer right now, and you will probably think it's not a good one. But I think it's the first answer, and for me at least, it's really the first question that I ask myself, and I ask the customer, and usually it helps me to kind of like make a decision. And it's the question that I asked earlier. So, is your application going to be used by 3 billion users worldwide? If not, then you don't need microservices. Because the question about complexity and scalability in this discussion is only about if we should choose microservices or not. So if the answer to your question is no, it's not, so my application, my system is not planned right now. It might be at a certain whatever, but right now it is not planned to serve 2-3 billion users around the world, then from my point of view, it's not something that's really suitable for microservices. I don't know if Bulent agrees. Maybe he has other ways.
3
to
billion
think
is a
about
kind of a lot, but yeah, I usually collect the non-functional characteristics of the system, let's say. From business perspective, I would like to see the cases, number of total user, number of concurrent users. The need for elasticity is important, I believe, because with a monolith, you hardly, if at all, you can hardly achieve elastic growth in the throughput and capabilities of the system. If we have such kind of case, then I would consider to create something with services, either micro, but in the end, in 90%, probably more than 90%, we don't need microservices at all. But if we talk about tens of thousands of concurrent users, and it's not very complex and long-lasting operational stuff, we can go with vertically scaled monolith. But if we are talking about, in terms of concurrency, 100,000 at least, I don't believe that with monolith we can easily handle this, because there will be, especially if there's an elasticity added. But yeah, it depends. Discovery phase is difficult. I personally, I didn't work for and didn't build systems like Netflix.
Yeah.
Systems that...
Me neither.
So this is...
But I worked on microservices for customers that didn't need them, so...
But I personally did. Customer came and said, as I said, I would like a microservice architecture.
Yeah.
There was an architect from the client side. Can you build this? I'm reading this. And I'm building the picture in my head. I was like, yeah, I can. This one is very challenging. Do you really need it? I've read in a book. Okay, understand. Let's do it then.
Or I watched a video. Or I went to a conference.
But it was a success in the end. Yeah? The system is inside.
I don't think that Netflix, take the Netflix example, I don't think that we're going to hit this number, but I aim to do it, and I need just to go to the market and
I'll tell them that Spotify runs on monolith, Stack Overflow runs, so there's a monolith application. These are also planet scale applications. So
again, it depends on the internal workflow, I would say, too. Because Spotify is one thing, it delivers content which is not big, in that.
Correct.
So we need to consider, there are many architectural characteristics that must be evaluated. Fortunately, or unfortunately, microservice architecture has a lot of pros, but these two cons, like complexity and cost, they usually change totally the game.
Yes, yeah, definitely. So, are there any other?
I have one quick question.
Yes.
Do you think the downfall of the microservices microservices pretty much was initiated by the new GDPR rules and all the regulations that are coming every year and making the data exchange harder and harder. So is this related directly? Did it help a little bit? What do you think?
So I don't know. I don't. The reason why we do this talk is because I don't think there's a downfall of microservices, and there should be one, definitely. But I'm not sure if GDPR has something to do with that, because usually, kind of like, when you talk with microservices, it's about data that's in the same system, so it kind of like already needs to obey to all the GDPR rules. And if that's implemented from the scratch, I don't really think that GDPR kind of like plays a role in this.
If I answer this question, I see in microservice architecture a natural step forward after the SOA architecture, for example. And if I bind this to GDPR, a very simple example, meeting GDPR requirements with a distributed system is probably easier than having a monolith system. Just because in distributed system, I can put the database on a region that's, let's say, in US, the same schema database in EU, and I will recite all the data for EU citizens in EU, also in US for in US, without mixing them. This is a primary objective. And with distributed system, I can split parts that needs to be recited here, and I can use them as a computing engine, but they will store their data in here, like replicated services for services. So with microservices architecture, I can easily, okay, let's say from technical perspective, I can meet these requirements. With a monolith, there will be a very long, if I don't have resources to keep a big vertical monolith, there will be a very big latency to go back and forth. I need to find a central place between database, or I need to deploy additional monolith in different region and to keep them separated. Again, GDPR is not something that introduces the need for microservice architecture. GDPR is something that can be implemented with nowadays technologies, probably elegantly, but who knows? It's difficult.
Okay, so I think we need to wrap this up. Yes.
Yeah.
As you mentioned, microservices sounds amazing. From your experience, what is easier to sell to the clients, microservices or
microservices? They always hear about it.
So, clients read papers.
Yeah.
Clients read, listen news and watch videos. You can sell them easily, AI-enabled or empowered system. You can sell them decentralized system that uses blockchain technologies to keep your data secure, uniquely stamped, etc. You can sell them any trending word that they hear somewhere, just because people like trendy things. Do you need Maybach? But there are people who like Maybach. If they can pay for Maybach, they will buy Maybach, not Mercedes, yeah? Just because they can buy Maybach and go from A to B like they will do with old Toyota.
And that's how we do things differently at Amdaris, because instead of kind of like proposing to customers microservices or things like this, we just really try to understand what are their business needs, what are their expectations and their requirements, and then propose them solutions that fit them best, both from a complexity, technology, and cost perspective. So, yeah, that's what we kind of like do internally.
As a consultant in Amdaris, we have an ultimate objective: to advise clients to take the best and the most valid and right decision regarding the system. Because in the end, if we oversell or upsell something that they don't need, it comes back and hits us. Yeah? That's why we are very clearly evaluating all of the needs in the very beginning during the discovery phase. And we propose, you don't need this, we don't need this, but having this that you cannot imagine that exists in this world, It's important because of these regulations that your business domain requires. So this is what we as a consultants, we really do, and this is a major objective. Otherwise, you cannot guarantee a sustainable business. Having such kind of consultancy business is not like hit and run, get the money, and this is not sustainable. You need to wisely and really with good arguments to explain to the customer why you need this budget of 5,000 per month for the cloud infrastructure and have it on a monthly basis really well described. Otherwise, you cannot do business with this customer in the long term.
Yeah. Okay, cool. So I think we need to move the discussions to the kitchen. I would really like, Bulent, to thank you very much for taking the time to have this discussion with me. Finally had the technology discussion face-to-face and not on Teams. That was kind of like really, really great. And thank you also very, very much for joining our discussion today. And if you did enjoy it, just let us know. If you didn't, also let us know. But if you enjoyed it, probably we'll try to organize something similar in the future also. And yeah, please be our guests in the kitchen. Let's have a chat. Let's grab something to eat. And yeah, let's keep chatting. Thank you very much.
Thank you very much.